Okay, so we'll just quickly recap what we discussed in last class, then we'll continue. So we have seen the dictionary, the last data structure, which is key value pair data structure. It is also ordered collection of data, mutable, and no duplicates allowed. So how do we create? We create using the curly braces. The same curly brace is used for the set, but how Python recognize because of the data we are passing in the key and value format. The key can be string, integer, float, anything, and the value also can be anything, any kind of data structure. Just remember, string should be immutable, which cannot be changed, which means our list is mutable, right? So you cannot have a key as a you cannot have list as a key because that can be changed. But you can have tuple as a key because tuple is not changeable, right? So blind rule is anything which cannot be changed only can act as a key. Then we also seen the constructor way of creating it. We have to just use dict constructor and pass as a key without quotes, then value as is how we were passing in the curly braces. Then we have seen if you have a multiple keys in a list of the tuple, and if you want to create a dictionary with a default value 0 here, we can use from keys. Then we have seen how to read a key value. We have to just pass key inside the square braces and we'll be able to read it. And this way, when you are reading, if the key is not present, we get the key error. That is where dot get method will help. If the value is there, it gives the value. Otherwise, the default value we are keeping here, it will return. Then we have seen how to add a new item. You just have to provide the key, then assignment operator, and what is the value you want to add. Update also same way. Basically the same thing. If the value is there, it will update. If it is not there, it will add. Then read and update or update both operations in a single thing. When you use set default method, if the key is present, you get the value. If the key is not present, it will be added with the value we are providing here. That is what set default does. Then we have seen how to delete item using the pop method. Pop does again same thing. It returns the value and remove. Pop item to remove the last item in the dictionary. Dictionary is also ordered one, right? So last one will be removed. And del method is another way of deleting it using the key. And if you want to clear all items in a dictionary, a dot clear will help in clearing all the values. Then when you give only the curly braces, how Python will know it is a set or dictionary? Python will treat it as a dictionary. If you want to create empty set, you have to go with constructor. Then we have seen copy. It's the same as list tuples where you just create a new copy. It will be stored in the new memory location. Then we have also seen membership operator. You can check if the key is present in uh, dictionary or not. We have seen how to fetch all the keys using dot keys method. Then we also seen how to get all the values using dot value method. And dot items will return both key and value in a tuple form. So the output will be from items is list of tuples. Then we can delete entire dictionary using del method the same way. Then we have also seen data structures conversion. How do we convert from one data structure to another using the constructors? If you want to convert it to list, you should use list constructor. If you want to convert it to dictionary, it will be dictionary converter. We have seen, right? If we have one values in one list, keys in one list, we can use zip method. Zip will take one item from here and one item from here, and it will make that as a tuple. So like that, it make all the tuples and as a list of tuples. And then once you pass that to dictionary, it will convert as a dictionary. That's how we can convert a list to dictionary. Then if you want to convert to tuple, it's a tuple constructor we have to use. Set is set. So why and how set is useful? Set will not allow duplicates. If your list is having a duplicates, you just have to convert it to set and again convert it back to list that we have seen. We can do both in a single line. List of set of vegetables. That way all the duplicates will be deleted and we get back the list. Frozen set also same way we can use the constructor. Then we have seen sequence types. List, whatever is having a indexing is the sequence type. We have seen list, tuple, string, and there is something called range. So range object is where it will return a range of values. This is a starting index, ending index, and step size, as we have seen in list slicing. It start from starting, it goes till end, but end is not included. Here we get only from 0 to 9 with step size 2, like 0, 2, 4, 6, 8 we get here. So the negative index also allowed, same way as we have seen in list. So when we convert a string to list, what happens? Every character will convert as a one item inside the list. Yeah, that is all we had seen on the dictionary. If anyone has any questions, I'm happy to answer. Otherwise, we can go to the next one. Okay.
Sharath, I have
Yeah.
a question.
Yeah. Yeah.
యాక్చువల్లీ ఇక్కడ కాదు లిస్ట్లో.
Okay.
సో లిస్ట్లో మీరు కన్స్ట్రక్టెడ్ వే ఆఫ్ చెప్పారు కదా,
Correct.
కండిషనల్ వే ఆఫ్ డిఫైనింగ్ లిస్ట్. సో ఆ కండిషన్ వేలో నేను డిఫైన్ చేశాక ఏదైనా ఒకటి అపెండ్ చేసి ఏదైనా యాడ్ చేద్దామంటే నాకు ఎర్రర్ వస్తుంది.
సో కన్స్ట్రక్టర్ తో మీరు ఇలా చేశారా? లిస్ట్ ఆఫ్ సపోజ్ సంథింగ్ ఇలా డిఫైన్ చేశారా కన్స్ట్రక్టర్
యా
తో?
యా ఇలా డిఫైన్ చేసి
ఓకే, వెజ్ తర్వాత వెజ్ డాట్ అపెండ్
స్టార్ట్ అపెండ్
సమ్ వాటెవర్. ఇక్కడ ఎర్రర్ వస్తుందా?
యా
యాక్చువల్గా రాకూడదు. లెట్స్ ఇది మనకు అయింది కదా. ఫస్ట్ వెజ్ ఫ్రూట్ మనం డిఫైన్ చేసాం ఇక్కడ కన్స్ట్రక్టర్లో, అది ప్రింట్ చేసాం. తర్వాత అపెండ్ గ్రాసరీ, గ్రాసరీ అపెండ్ అయిపోయింది. మేబీ ఇక్కడ సింగిల్ బ్రేసెస్ ఏమైనా ఇచ్చారా? సింగిల్ బ్రేసెస్ ఇచ్చే ఫెయిల్యూర్ వస్తుంది, ఫెయిల్ అవుతుంది.
లేదండి, డబుల్
డబుల్
ఇచ్చా.
ఇచ్చారా? ఓకే, క్లాస్ అయిపోయిన తర్వాత చూద్దాం శ్రీరామ్, స్క్రీన్ షేర్ చేసి.
సరే సరే సరే
ఓకే,
సరే సరే.
let's go to nested data structures. This is very important. Nested means one data structure inside another. So now let's start with the list. Okay, what do you say? Let's say same again. Let's take shopping. So what I am doing, right? I am creating, let's say, first vegetables, same way, then onion. But now I want to go with fruits, apple, then orange. So these are two categories, right? So I want to somehow differentiate them. So what I can do, I can actually keep them as a list of list, list inside a list. That is allowed. The nesting is allowed in any data structure. Then I can even have something else, right? Some kind of groceries, right? S- So here we have three lists inside a list. You print it the same way, it will get printed. So first we have main list, inside we have sub list. So now when I give shopping with index 0, what should I get? What 0 does? 0 returns the first item in the list where I am trying to fetch, right? Shopping is our main list, inside which whatever is the first item that will be returned. So what we get? We get first list returned because first list is the first item in the main list. That is how we get the first list. Same way you can pull second one, third one also using the same indexing concept. Now, suppose if you want to pull only tomato out of this, how do we do that, right? So when we pulled shopping with index 0, what we got? We got tomato and onion, right? Now imagine this as a new list, right? Let's say I'm just keeping it as which. So we know from this list how do we pull tomato, right? What we do, we give the index 0, right? And then we pull. So here whatever we are assigning to wedge, right, that is same as what we are getting here also, right? Whatever object you are getting from any operation, you can chain the next operation, right? So shopping 0 is also list here. This is also a list, right? Shopping 0 is also same list, wedge also same list. So how we give index for wedge to get the first item? The same way we can do to the shopping 0 also. So shopping 0 is giving me a sublist. Inside that sublist, if I want first item, I can just add one more index with 0. That is how we can pull tomato from sublist. Let us print. You see, we got tomato now. How we got? First, shopping is the main list. Inside the main list, I'm going to first index. First index is a sub list. In the sub list, I want again first item. So 0 comes. This is how we can pull data from nested data structures. Okay. Let's say, let me keep this as a tuple, right? So in the tuple also the same indexing concept, right? So now if I want to pull orange, so what should I give now here? First, the main one. Which
One
index
comma.
it, it is 1, right? 1. And again inside my tuple, where is orange? It is again at 1 in index 1.
One, one, one.
Yeah. So if we give 1 and 1, then we get orange. Now let's change this to something else. Okay, I'm changing it to dictionary. Uh, Grocery equal to, just I'm keeping something pulse. Now, how do I get this pulse? I want this pulse value, right? So first in the main parent list where I am at, I am at index 2, right? So let's go to index 2. Once we print index 2, what we got? We got a dictionary. So from this dictionary, how do I get pulse? I have to query with the key. So what I have to do? I have to just give the key value here. So first is list. I am going with index. So inside that index 2, I am having a dictionary. So in the dictionary, I have to pass a key to get the value. You see, we got the pulse. You can, let's say, if you have some text, right? Let's say final bill something. I'm just keeping a string, nothing else, right? So if I take index 3, right, I will just get final bill. You see, this index final bill is what? It is a string. So now you can apply all your string methods, whatever we have seen, right? Dot upper. So what this operation is returning, that matters. If this is returning a string, I can apply whatever I do for the string. If this is returning a dictionary, I can do whatever I do for dictionary. Same way, if this is a list, whatever I can do for a list, I can do. That is how the chaining works. So execute, you see, I got the final bill.
Is this applicable only for list or
No, no,
anything
no.
else?
See, list is immutable, right? Sorry, we are all just reading so far, right? It is applicable for anything. It is just reading. Let me take. Yeah, I'll come to next also. Next one
Okay,
also.
okay.
We'll keep something inside the dictionary, then inside a tuple, then inside a set. We will see all the combinations. Now, upper also we have seen. Let's say I just want to pull only uh, bill from this word. So how can I pull only bill from the string? Again, string also sequence type goes with the indexing, right? So 0, 1, 2, 3, 4, 5. From index 5, I have to pull, right? So if I just do index 5 until end, that is what I want, right? Let it be upper. That doesn't matter to us. So we got only bill because for the string I applied indexing. So what else? We can even have set, right? The same sets we have seen. I'm just keeping something for now. You can also set there is no indexing concept, so you cannot really retrieve one out of it, but you can retrieve whole set. You see, we got B and A. There is no guarantee of order, so first B came, then A came. That's how set works. So now, like this, right? The nesting is allowed to any level, not just two levels. You can go. Let's say I am keeping something here. Okay. So what I am doing now? First, I have
Sharad, I just missed where you define the bill.
final bill is a string, just a string we have. Okay.
Okay. Uh-huh.
From the
You
string,
assign
from,
value.
I didn't assign. From the string, I
Mhm.
am pulling out only bill using the indexing concept.
A substring.
Okay.
Yeah, substring. I am starting from 5 till end. That's how I get the bill.
Okay. Okay.
Then I
Okay. Got it.
apply dot upper. That is how I got this bill.
Okay. Got it.
Yeah. So
Uh,
now,
Again, the string is they consider as a list, and from there you pull it out.
We
the main
print the characters.
we start from the
Mm.
higher level.
Yeah, yeah, yeah.
Go inside.
Got it.
Now let's see this example where we go to third level. Right. So we have a grocery. Inside the grocery, again I am keeping a list. Right. So now, how do I get sugar from this? First, where is the main one? First, we need to come to the index 2 in the main list, right? So index 2. So once we are at index 2, then what we have? We have a dictionary, right? So how do we come to this list? Using this key, right? So now after that we have to give the key. Then once we are at this list, we want to pull sugar, right? What is the index of the sugar? That
One.
is 1, right? That is how we can pull sugar. You see, we got the sugar. So just understand the concept that you just have to keep going and get that value. If it is a list, go by the index. If it is a dictionary, go by the key. That's how you can go to any levels, any number of levels. There is no limitation. Right? Now, okay, we have seen reading the items. Now let's understand how do we update items in the nested data structures. Okay. Let's take, okay, I want to add one more item here. Are we allowed to add? Yes, because it is a list. It is a mutable thing, right? So same way. First, how do we come to this list? Using the shopping zero. Shopping zero will give us the first list, right? Now we are at the list.
Yeah.
How do we add a new value to a list?
Append.
Dot append. I am just adding one more. So let's print and add it, execute. You see, the key is added now. The same way, how we are pulling the value, same way you can update also. Second one is a tuple, you cannot do anything. Tuple is immutable, right? Let's add something to our dictionary. So where is our dictionary? Dictionary is index 2. Let's say I want to add one more item, right? One more key. Mm, something I'm adding. Maybe C equal to, I want to add some value. Let's say EF. If you print shopping,
You're adding only key, right? Oh, the values. Okay.
it is showing me some error. Okay, let's see. Let's execute and see what
Dot
happens.
dot add or something.
No, right? It is added. Dictionary, though, you just give the key and value, right? It is added.
Yeah.
Mm-mm.
I don't know why this is showing this. Unexpected type string supported index. Okay, doesn't matter. It is unnecessarily confusing us. So it is added. We just wanted to add one more key to our existing dictionary inside a list and it is added, right? Let's say now I want to add one item here. Or let's say we want to update sugar to jaggery. Okay, so how do we do that? Shopping. First, how do we get into same this dictionary using the same index 2, right? Index 2 we are. Okay. Then how do we get into the sublist inside the dictionary using the key value?
Glossary.
Key value.
Uh, Now, which value we want to update? We want to update sugar, right? Index 1 is the sugar.
Mm.
That we want to update it to jaggery. Print shopping. This is how you can update value. Jaggery is here. Just go one level at a time. Okay, first go to, okay, I'm going into item number whatever 3 index 2. Then inside I have to go, so use the key. Then inside where I need to go, so keep going this way till wherever you want. Understand the concept, that's it. So this nested data structures are something we use in day in day out in real time.
Oh,
Yeah, so this is how data, real world data will be, right? It will not be like a simple list or simple dictionary, right? You have
yeah.
seen.
I'm always getting doubt. Like now we are using just 4 or 5 indexes.
Exactly.
Let's say if you have like thousands of indexes, how do you find
That is where loops will come to picture. What do you want to do with the loops? Just go one by one, your program does everything, right? In the loop until the data is there. Okay.
No, no.
And
My question is like if I want to find the index number, 100 indexes are there. Now we just guessing, seeing by seeing the list, you can figure
correct,
it out which is the index number.
correct.
Then how the loops comes into picture there?
Um, See, your real-time requirements will not be like, okay, third index, find sugar, then replace jaggery. It will have some
Hmm.
meaningful requirements, right? Let's say if you are
Hmm.
getting a individual uh, transactions for some customer, right?
Hmm. Hmm.
I want sum of those transaction value for each customer.
Hmm.
So you go by customer ID, take all the marks, you keep appending to separate list. Okay, let's say this is a dictionary. Let's say Srikanth, okay, is customer.
Hmm.
So I keep adding values, whatever transaction value I have.
Hmm.
One more customer, right? I
Hmm.
have to prepare this data structure first. 200. You should somehow collect this data. Then you can add these values and prepare the transaction total and keep that as a separate dictionary. Basically,
Hmm.
there is no such use cases where you have to go with certain index and find certain value. It's all about complete transformation of the data, what you wanted to do.
Yeah, understand. Now let's say in Srikant dictionary, the 500 is incorrectly updated.
Hmm,
So I want to append that one. So now by looking at this list, I can find it. This index is 4.
correct.
But if it is like huge data,
Okay, good question. First of all,
uh,
my question is, how do you know this 500 is incorrect here?
I mean, user complaint 500 is incorrectly updated,
Uh,
or
See, there should be some kind of logic behind it, right? How you
okay,
arrived at that 500 is incorrect.
maybe the date or something. Uh-huh.
Like that logic only we have to put in the program again to identify all those incorrect values.
I see.
Yeah.
Hmm. Okay, understand.
Okay, what I wanted to show. Same way, you can have anything in the dictionary also. So now let's say this will be some meaningful shopping cart. Okay. So now I want to get some vegetables. Okay. This is my vegetables list. I just keep, then same thing, right? This is one key and value pair. The next one, now this is a proper separate categories, right? So I'm keeping key, then list of values. Okay. So like this, I can go on. Again, let's say if we want to retrieve onion from here, how do we do that? First, what is the key? Is the vegetables. Then we get the list. So inside the list, where is my onion? It is at 1. This is how I get onion. The same concept too. The chaining concept we should use. This is how the JSON data will be. JSON data will be of only dictionary and a list. I will show you.
Yeah,
You remember in the demo class, I showed one website, right? Let me show you that now.
yeah. We used to work with JSON files. Yeah, I know.
Inspect. Now it should make more sense to you when you look at the data. Network, etc. Now I'm just checking from Bangalore to Hyderabad. That's okay. Any day. Now where is our API? Get bus list. This is our API. It is returning us some data. Okay. It This is like a preview where they are giving you this collapse and expand options. If you go to response, it's not loading only. Okay, use data. Like you see curly brace here, right? Started with status. Status is the key. What is the value of that? You got success. Then next key. Then you got it. And when you come to this blocking list, right? Blocking list is a key. You see value. Value is a list, right? This is a list. And inside list, you have again key value pair. See, they are giving you index 0. At index 0, you have again one more dictionary. In the dictionary, you have API as key value, key value, key value. Again, inside that, there is one more key. It has again list. Inside that, again, you have index 0, 1, 2, again dictionary. This is how the JSON data in the real world. It's all list and dictionaries.
Mhm.
When we are developing any REST APIs, right? This data we have to prepare in the backend this way and give to frontend. There will be some agreement between frontend and backend. Okay, I want data in this way. So we have to prepare data in the same way and give to them. Then only they will be able to interpret and show in the UI. Okay. So that's how list combination with the dictionary is very important. The other combinations are rare. They are not much used in real time. You know the reasons, right? They are immutable. Like if you use tuple, it's immutable. You can't do much about it. Set also, you cannot do much updates, right? But
This Sharad.
yeah,
So this instead of vegetable, can't we use the indexing for that as well? Zero.
there is no indexing in the dictionary, right? It's only key value
Okay.
pair.
Yeah.
Okay. Okay.
Yeah. Always take that. Okay, what is shopping? Shopping is a dictionary. So what is applicable for dictionary? You apply that. So now you applied the key. What this is returning? This is returning me the list. So now what is applicable to list? You can do everything. So indexing is allowed. So I do indexing. You can do slicing also if there are more items, right? Slicing is also allowed. Just treat that as a okay. Now this is a list. I do now list operation. That's all. So what else? Okay. Um,
అవుట్ ఆఫ్ కాంటెక్స్ట్ క్వశ్చన్.
yeah.
ఇప్పుడు మీరు అభిబాస్ చూపించారు కదా!
అవును.
సో ద లిస్ట్ అండ్ దట్ అది పైథాన్‌లోనే అంటే మీకెట్లా తెలిసింది అది పైథాన్‌లోనే రాసారు అన్నట్టు?
లేదు,
లేదంటే
గ్యారంటీ మనకేం అవసరం లేదు కదా. ఇట్ కెన్ బి ఇన్ ఎనీ లాంగ్వేజ్ బట్ ద స్ట్రక్చర్ ఈజ్ వాట్ జేసన్.
ఓకే. ద జేసన్ ఆల్సో ఫాలోస్ దిస్ లిస్ట్ సెట్ అండ్ ఎవ్రీథింగ్.
Yes.
ఓకే. ఓకే. ఓకే.
JSON will contain only list and dictionaries in the Python way, in
ఓకే.
Python world, I would say, right?
ఓకే.
There are some modules. If you pass your data to that module, it will tell you whether that is a correct JSON data or wrong JSON data. Okay, if your dictionary contains sets, tuples, right? Some
హుహు.
data types are not supported in JSON data, so it will throw error that I am not able to pass this as a JSON data.
హుహు.
So we will see in the module section. I'll cover that is called JSON module in Python.
యాహ్! యాహ్! అండర్‌స్టాండ్. ఓకే.
Okay. What other
అంటే
important?
జేసన్ బేస్డ్ ఆన్ ద ప్రోగ్రామింగ్ లాంగ్వేజ్ స్ట్రక్చర్ మారిపోతుందా?
Hmm.
లైక్ జావా అయితే
లేదు.
ఒకలాగా, పైథాన్ అయితే ఒకలాగా.
అది కాదు. అది
JSON
కాదు.
అంటే ఎప్పుడు ఈ ఫామ్ లో ఉంటుంది. ఓకే, కీ
హ్మ్. హ్మ్.
వాల్యూ పేర్ ఆర్ లిస్ట్, ఓన్లీ టూ.
హ్మ్.
Either you go by key value pair or only list, only two are allowed. సో కీ వాల్యూ పేర్ పైథాన్ లో ఏంటి? డిక్షనరీ. లిస్ట్ వచ్చేసి లిస్టే. సో ఆర్ అండ్ ఏ ఇప్పుడు సపోజ్ జావాలో అయితే వాళ్ళు డిక్షనరీని ఇంకొకలాగా పిలవచ్చు దాన్ని.
హ్మ్.
లిస్ట్
హ్మ్.
ని వాళ్ళు అరే అనొచ్చు. వాళ్ళు ఏ లాంగ్వేజ్ లో మాట్లాడినా ఫైనల్ గా వచ్చే ఫైనల్ డేటా ఇలా ఉండాలన్నమాట.
హ్మ్.
కీ వాల్యూ పేర్ అండ్ అరే లాగా. ఇంకా స్ట్రింగ్స్ అన్ని
సరే.
అలౌడ్. స్ట్రింగ్స్, నెంబర్స్ అవన్నీ అలౌడ్ ఉంటాయి ఇలా.
హ్మ్.
యాహ్! ఐ కెన్ కనెక్ట్ ద డాట్స్ యాక్చువల్లీ. మేము నా పాత కంపెనీలో జేసన్ ఫైల్ మేము రిక్వెస్ట్ రెస్పాన్స్ కోసమని యూజ్ చేసేవాళ్ళం అనమాట. అందులో
ఎగ్జాక్ట్లీ.
అడ్రెస్ ఫీల్డ్ ఉండేది. అడ్రెస్‌లో నేము అవి మేము మార్చుకుంటూ జేసన్ ఫైల్‌ని ట్రిగ్గర్ చేసేవాళ్ళం అనమాట. సో,
ఎగ్జాక్ట్లీ.
ఐ థింక్ నౌ డిక్షనరీ దట్ ఈస్ యాక్చువల్ డిక్షనరీ. ఆల్ దిస్ ఫైల్ ఐ వుడ్ యూజ్.
No, we cannot
ఓకే.
call dictionary because JSON is
యాహ్!
a
యాహ్!
global word and dictionary is only Python word.
యాహ్! యాహ్! యాహ్!
Mm.
ఐ మీన్ లైక్ ఇన్ పైథాన్ టర్మ్ ఇట్స్ ఎ డిక్షనరీ.
Dictionary, correct.
యాహ్!
See, when we are returning something from REST API to front end, right? We write it as a
హ్మ్.
dictionary only and return that.
యాహ్! యాహ్! మేము పోస్ట్‌మ్యాన్‌లో పోస్ట్ చేసేవాళ్ళం అనమాట రీసెంట్.
Exactly. Postman లో. సో కాన్సెప్ట్ అర్థమైంది కదా.
సో అక్కడ
అంటే
యాహ్!
లిస్ట్‌లో లిస్ట్‌లో డిక్షనరీ యూజ్ చేసాడా?
ఆ, అలా కూడా ఉంటది కదా. ఫస్ట్
అదే.
చూసాం మనం.
అదే. అదే.
ఎనీథింగ్.
JSON
అదే
అంటే
అక్కడ
ఎప్పుడైనా
చేసాం.
హై లెవెల్లో డిక్షనరీనే ఉంటది. లిస్ట్ తో కూడా ఉండడం
హుహు.
వ్యాలిడ్, బట్ ఎప్పుడు డిక్షనరీతోనే ఉంటది. సో
కింద ఇందాక లిస్ట్‌లో డిక్షనరీ వచ్చింది. ఇవన్నీ
అది
గూడా.
నెస్టింగ్ ఈజ్ అలౌడ్ టు ఎనీ లిమిట్. అంటే లిమిట్ అంటే ఏం ఉండదు. డిక్షనరీ
హుహు.
లోపల లిస్ట్ లోపల మళ్ళీ డిక్షనరీ, ఆ డిక్షనరీ లోపల మళ్ళీ లిస్టు, ఇట్లా వెళ్ళిపోతూనే ఉంటది.
హుహుహు.
సో బట్ ఎలా మనం అప్డేట్ చేయాలా, ఎలా రీడ్ చేయాలా డేటా అనేది సేమ్ కాన్సెప్ట్. గో వన్ లెవెల్ అట్ అ టైం. ఫస్ట్ ఓకే, లిస్ట్ దగ్గరికి వెళ్ళా, మళ్ళీ లిస్ట్లో ఇండెక్స్ దగ్గరికి వెళ్ళా, ఇంకా వాల్యూ ఉంటే మళ్ళీ వాల్యూ. సో అట్లా చైన్ అమ్మని వెళ్ళిపోతూ ఉంటే మీకు వాల్యూస్ వస్తూ ఉంటాయి. ఇంకా లూప్స్ తర్వాత ఇంకా బెటర్గా అర్థమవుతాయి. అంటే లూప్స్ యూజ్ చేసి ఎలా ఈ డేటా మొత్తాన్ని మనం రీడ్ చేయగలం అనేది.
ఓకే.
ఓకే.
ఓకే, సో టపుల్స్ లోపల టపుల్ ఈజ్ ఇమ్యూటబుల్, రైట్? సో random, I'm just giving rand. టపుల్స్ లోపల ఇలాంటి రియల్ టైంలో లేవు, బట్ నేను జస్ట్ ట్రై చేస్తా ఉన్నా. 1 2 3, let's say this is what we have and see if we can change the 1 2 3. Okay, now so how do I update 1 2 3 rand of 1, right? Index 1. To that I'm appending, let's say 4. Print rand. See, we are able to do this. How we are able to update, though it is a tuple. Okay, we talked about memory location, right? When it is some string, okay, it is stored in some memory. Let's say it is stored in 1 2 3, right? So how the data structures stored, nested data structures especially, right? So in this case what happened, right? The rand tuple is stored at location, let's say 3 4 5. The 3 4 5, what it has, it has tuple the memory location of a, location of string a. Okay, then next it has memory location of our list. This is how internally it will contain our RAND, memory location of our string a and memory location of our list, right? The string a you cannot change because it is immutable, but the list, right, it is mutable, you can change, right? So when I added 4, what happened? Let's say the 1 2 3 1 2 3 memory location is 6 7 8, right? When I added the 4 here in location 6 7 8, the data is updated to 1 2 3 4, right? So when I am printing rand, what happened? It is just taking the value in this memory location, that is a remains same. Next, the memory location 6 8. Whatever there in the 6 7 8, it will just give you the output. That is how, though it is a tuple, we are able to update items inside because it goes by the memory location reference. Got it?
Yeah. But you cannot add that extra, like, after one, two, three,
No,
add
no,
one
no.
more.
Tuple will not allow anything, right? You cannot add rand of, let's say, uh, append. There is no append method. Even you can't
Yeah.
update rand one to something else, right? Because it
Yeah.
will fail. And this memory concept is very important. I'll come to that. Yeah, and what sets also the same way.
Shut
We have,
up, sir. Repeat, shut up.
okay.
It's never.
Huh. So here we have a tuple which is immutable, which means you cannot change anything, you cannot update anything, right? But we have a list inside and we are able to update that list. How? How the update is possible though it is a tuple? How Python saves this in the behind scene is, it don't save entire tuple at one memory location. Okay, it saves the internal data, then refer the location of it. So here, let's say string A is at 3 4 3 4 5 location, right? Then 1 2 3 is at memory location 1 6 7 8. So internally how it will be? It will be like 3 4 5 memory location is first item. Memory location 6 7 is the second item in my tuple. This is how Python treats it. So what I have value at 3 4 5 is A. What I have at 6 7 8 is 1 2 3. Now I have come and changed this list. I have updated new list, new item to this list. This is a list and it allows the updates, right? So it allowed and I added 4. The 4 is updated in the memory location 6 7 8. The 6 7 is 7 8 data has become this. Why our tuple is not bothered? Because it is referring to only memory location. Whatever is there in memory, I'll just return. That's not my problem. So when I print rand, it is just returning what value I have at 3 4 5, which is A, and what value I have at 6 7 8, that is 1 2 3. Not 1 2 3, we updated, right? It is 1 2 3 4.
Got it.
Okay. Uh, Set is also on the same line, similar. You can just update. Okay. random 2. I'm just having something A, B. So let's see capital A, small a. These are two different in Python. They are not duplicates. What else? I'm adding some list. Let's say list.
sorry
Yeah,
Sarat.
yeah.
సో టపుల్లో బేసిక్గా మనం ఫస్ట్ డిఫైన్ చేసిన లొకేషన్స్ ఫిక్స్డ్ అయిపోయి ఉంటే దాంట్లో వేరియబుల్స్ స్వాప్ చేసుకోవచ్చు అంటున్నారు మరి
ఆ ఆ లొకేషన్ లో డేటా ఏమైతే ఉంటుందో అది ఎప్పుడైనా ఇస్తుంది మనకి మనం ప్రింట్ చేసినప్పుడు. సో ఆ మెమరీ
డేటా ఆ మెమరీ లొకేషన్లో ఉన్న డేటా వాల్యూ కూడా అపెండ్ చేస్తాం కదా ఇప్పుడు అదే కదా.
అవును, కరెక్ట్.
ఓకే, సో అక్కడ ఏ బదులు దాన్ని మనం బి కూడా చేసేయచ్చు.
ఇది ఇమ్యూటబుల్.
బి చేయలేము, ఏ బి చేయొచ్చు కానీ ఏని బి చేయలేము.
ఇది ఇది ఇమ్యూటబుల్ ఆబ్జెక్ట్. స్ట్రింగ్ ఈజ్ ఇమ్యూటబుల్.
ఓకే, స్ట్రింగ్ ఇస్ ఇమ్యూటబుల్. ఓకే, ఇది లిస్ట్ కాబట్టి లిస్ట్
ఇమ్యూటబుల్ కాబట్టి
అప్డేట్
ఇక్కడ
చేస్తాం.
అప్డేట్ చేయొచ్చు.
ఓకే ఓకే, గోట్ ఇట్.
Okay. So now this is just set, right? So see these exam set inside tuple, these are rare in real time. The only one is JSON. Okay, unhashable type. So list is not sorry, set is not allowing to have a list. It is showing unhashable, right? Unhashable in other way is which is not changeable. It should be static and it cannot be changed. List is mutable, right? It can be changed. Wherein our tuple, it not it is not changeable. That is what hashable in programming world. You remember in dictionary also key, when I was talking about key, it should be only immutable object, right? Actually it should be hashable. In other word, only whatever is hashable, whatever is not changeable can be kept as a key in a dictionary. So same way here also it is not allowing non-hashable objects. It's only hashable, which means immutable objects. So there is no guarantee of the order, but you can just append. Nothing to worry much. Set, as far as my knowledge, my experience, it is used to eliminate the duplicates. Or if you want to find the differences between two big lists, right? Or two tuples, you convert them to set, and dot difference methods, dot symmetric difference methods, right? Dot intersection. We use only those, nothing else. Okay. That's all on the data set, nested data structures. So this is important. First one, inside a list, list inside a dictionary, dictionary inside a list. Just simple rule. Go by one level. Okay, what it is returning, dictionary. Next, go to next level. Give a key. Then again I got a list. Okay, then go with index. That one rule will help everywhere. Even if it comes it as a tuple, string, whatever, the same rule. So that is about the nested data structures. So I'll cover one more small topic, then we can close today. Okay, shallow copy versus deep copy. Okay. Before I explain, let me take an example. Hmm. Okay, let's take same thing. Shopping, vegetables. I'm giving a list as tomato, onion. Okay, so now you remember the copy method we were using, right? What copy does? It takes the data and puts it in a new location, right? And whenever we change original one, this is not affected. That is what we have learned so far using the dot copy method, right? So
It's
now,
like taking a backup.
it's taking like a backup. Now let's see how the data displayed here. Okay, we have defined this dictionary. We took a copy. We are just printing both. Now what I am doing, shopping, I am taking veg, then I am adding a new value. Okay, chili. Now I want to print both. Now you see what happened. First, we had this one, right? Veg, tomato, onion. Then this was the copy we took. We added one item to our shopping, but you see that has affected our shop copy also. Okay, how? How this has happened? So this is called shallow copy. In the shallow copy, it copies only the parent items. Okay, in the behind scene, how it works, right? Let's say this is in one memory location, right? Basically, veg is a string, right? It is not assigned to any variable, so it now the dictionary itself will keep this veg in some memory location, right? Let's say 987 memory location. Then it is referring to the value which is again a list at different memory location 876. Okay, in the shallow copy world, only first ones are copied. So how it would have happened in the behind scene is the wedge is copied to different location, let's say 107, but the value it is still pointing to 876 only. That is the reason when I changed something in the list, that is my 876 memory location, our copied or backup list also is affected because it is just pointing to the memory location. It has not copied this value, only the reference. The copy happens only to the first level of data what we have here. Okay, now let's see first level data what happens. Shopping, I'm adding one more thing, let's say fruit, right? I'm adding a list apple, and then let me print. You see now the fruit is affected only for the original list, but it is not affected for the backup or copy list what we have. That is because this is at the first level, which is new, right? That is added later after backup. But the inside data structure what we have, it is not created. There is no new copy created of this data. It's only existing data. Understood this concept? One more time. Okay, let me try.
So one question:
Hmm.
if the main pointer removed, it
Hmm.
should be impacted to the reference, right?
First one is removed. Which one?
The first one removed wedge. Suppose we removed a shopping in that
Huh,
wedge,
huh.
so should it
No,
impact the reference?
no, it should not because this is copied. This is already copied, right?
Mhm.
Okay, let me show you that
Okay.
also. Such a good
ఇదంటే సి
concept.
But
సి లాంగ్వేజ్ లో పాయింటర్స్ ఉండేది అలా కదా.
but
C language
876 ప్లేస్ లో ఇంపాక్ట్ ఉంటుంది.
లేదు 876 అనేది ఒక మెమరీలో స్టోర్ అయింది కదా, ఒక మెమరీలో
అవును,
సపరేట్ మెమరీలో
అది
ఉంది.
క్లియర్ చేసేస్తున్నారు కదా, ఇప్పుడు డిలీట్
అది
చేస్తే.
మళ్ళీ 107కి 876 పాయింట్ అవుతుంది కదా.
సి
ఓకే
మనం
ఓకే.
మనము డిక్షనరీ డిలీట్ చేయగానే మెమరీ క్లియర్ అవ్వదు ఇమీడియట్ గా. ఓకే, బ్యాక్ ఎండ్ ఇంకొక మెకానిజం ఉంటుంది గార్బేజ్ కలెక్టర్ అని చెప్పి. సో ఆ గార్బేజ్ కలెక్టర్ ప్రాసెస్ మెమరీలోని డేటా ఎక్కడైనా వాడుతున్నారా లేదా అని చెక్ చేసి డిలీట్ చేస్తారనమాట. సో నువ్వు ఈ
ఓ
డిక్షనరీలో వాడిన డేటా ఇది మెమరీలో ఉంది, నువ్వు డిలీట్ చేసినప్పుడు
ఓకే
ఏమవుతుందంటే నువ్వు ఈ మెమరీని వాడుకోవట్లేదు అంతే.
ఓకే 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 వాల్యూ డిలీట్ చేస్తున్నా కానీ మెమరీ
మెమరీలో అది అలాగే ఉంటుంది.
రెఫరెన్స్ మెమరీ రెఫరెన్స్
చూడు
ర్యామ్లో లాగా ఉండిపోయింది అంటారు.
ఇది ఇలాగే ఉంది. షాపింగ్ కాపీ వెజ్ మనము షాపింగ్ నుంచి డిలీట్ చేసేసాం. అర్థమైందా? లేదంటే వేరే వేరే వేలో ఎక్స్ప్లెయిన్ చేయమంటారా?
అదే నేను ట్రై చేశాను ఆల్రెడీ, అదే డిలీట్ కావట్లేదు.
ఓకే ఓకే,
అదే ఎందుకని ఆలోచిస్తుంది.
నేను ట్రై చేస్తాను ఇంకొకసారి.
అదే
ఎనీ డౌట్స్ ఉన్నా మీకు క్లారిఫై అవుతాయి.
అర్థమైంది. బేసిక్గా అది మెమరీ రెఫరెన్స్ అంతే ఉంటుంది అంటిల్
లొకేషన్
ఫోర్స్ఫుల్ జీసీ క్లియర్ అయిపోయి అది లొకేషన్ రెఫరెన్స్
కరెక్ట్
క్లియర్ అయ్యేంత వరకు.
కరెక్ట్. సో
ఈ
లెట్స్
షాలో
సీ,
కాపీ అనేది ఓన్లీ డిక్షనరీ కీ
ఏ
అండ్ వాల్యూ
ఏ
వాడుతుంది.
డేటా స్ట్రక్చర్లో వాడినా ఇట్స్ ఓన్లీ ద ఫస్ట్ లెవెల్ డేటా విచ్ ఈస్ కాపీడ్. లెట్స్ సే ఇందాక మనం ఏ ఉంది కదా, సో నెక్స్ట్ వీ హ్యాడ్ ఏ లిస్ట్ 1 2 3 ఉంది కదా ఎగ్జాంపుల్, రైట్. సో ఇప్పుడు ఇక్కడ ఫస్ట్ లెట్స్ సే షాప్, రైట్. ఇది లెట్స్ సే ఏ, దెన్ 1 2 3. నా స్క్రీన్ కనబడుతుందా? చిన్నగా అయిపోయిందా?
లేదు బాగానే ఉంది, పర్వాలేదు.
బాగానే ఉంది.
ఓకే 1 2 3. సో ఇప్పుడు ఇక్కడ ఏమైంది? బిహైండ్ సీన్ స్పేస్, ఇప్పుడు ఇక్కడ మన మెమరీ లొకేషన్ 1 దెన్ మెమరీ లొకేషన్ 2 ఉంది కదా. సో నేను ఎప్పుడైతే షాప్ కాపీ తీసుకుంటానో యూజింగ్ షాప్ డాట్ copy మెథడ్, అప్పుడు ఏమవుతుందంటే there will be one more A created for shop copy, but ఈ 1 2 3 ఉంది కదా, this 1 2 3, this is referred here, this is referred here also, both. But A వచ్చేసి two different copies. So on a first level, whatever values you have, right, they will be copied into new memory location. That is why when we change something here 1 2 3, which means you are changing something indirectly here, right? So whatever objects are referring to this memory location, everywhere it is reflected. That is how in the shallow copy only the front ones are actually copied to a backup, but remaining and all referred by the same memory location. Got it?
ఈ
So
మెమరీ
when you
లొకేషన్, సారీ, ఓకే కంటిన్యూ వెనుగర్.
ఇప్పుడు ప్రింట్ షాప్ కాపీ అన్నప్పుడు ఇట్ రెఫర్స్ టు ద 107 మెమరీ అడ్రస్కి వెళ్ళింది, అక్కడ దాన్ని 87కి రెఫర్ అయింది,
When
8776 నుంచి ప్రింట్ చేసింది, అంతేనా?
అంతే. సో ఇప్పుడు ఈ షాప్ కాపీ అనేది నేను ప్రింట్ చేసిన అనుకోండి, ఏమవుతుంది? ఫస్ట్ కీ వచ్చేసి మెమరీ లొకేషన్ 3 నుంచి తీసుకుంటుంది, వాల్యూ వచ్చేసి మెమరీ లొకేషన్ 2 నుంచి తీసుకుంటుంది. ఓకే, సేమ్ వే షాప్ నేను ప్రింట్ చేసినప్పుడు ఏమవుతుంది? మెమరీ లొకేషన్ 1 నుంచి కీ, మెమరీ లొకేషన్ 2 నుంచి వాల్యూ వచ్చేస్తుంది. సో వాట్ ఎవర్ ఐ am changing to this to memory location, right, that is reflected here, because both are pointing to same data. There is no copy as such created. So
So when you are deleting key A,
hmm,
సో
you
ద
are
కీ ఒకటి డిలీట్ అవుతుంది కానీ దాని మెమరీ లొకేషన్ 2 అనేది అంతే ఉండిపోయింది.
correct. ఇక్కడ ఈ 1 2 3 అనేది ఇట్స్ నాట్ యువర్ డిక్షనరీ డేటా, ఇట్స్ నాట్ షాప్ డేటా. ఇట్ ఈస్ ఏ separate list data which shop is just referring. సో ఒకవేళ మనం డిలీట్ చేస్తే, when we delete this shop, right, only the reference to this, right, reference to this memory, whatever 1 2 3 were going, right, that is dropped, but this is still there in the memory, and this is still accessing that, right. That is, so you are still getting in shop copy, but shop is, it is deleted.
ఓకే ఓకే,
Got it?
ఈ అడ్రస్ని ఫ్లష్ చేయొచ్చా మనం?
అడ్రస్ ని
అడ్రస్ లొకేషన్ ఉంది కదా, దాన్ని ఫ్లష్ చేయొచ్చా?
ఫ్లష్ అంటే
అదే
అర్థం
అదే
See,
అదే అదే
in Python there is garbage collector which keeps running in the background, right? It keeps checking whether this data is used anywhere or not. If it is not used,
లొకేషన్ లొకేషన్ అంటున్నారా డేటా అంటున్నారా?
data. See what it does, right? It Python goes by, see Python has this data in memory, RAM, right? All the memory locations. It takes these two memory location and check, okay, uh, uh, are we using these two location anywhere? See whether this is the location data, it's all same, right? It is pointing to same data. So
Yeah,
it checks. Hmm.
so that means it's checking that location. Is
Huh,
that location
correct.
referring to any other place or not?
Exactly.
Yeah, okay.
In simple words, if the data is used or not.
Yeah,
If data is
okay.
used, I should not remove. If data is not used, then I should remove. It's not required, right? My memory is wasted.
Mm, mm.
That is how the garbage collector keep running. So, okay, if you want to remove immediately, right? There is a module called GC which you can use in Python, and that you are actually running the GC process manually. I will show that
So
later.
that means if you run the GC, so wherever that memory has been
Unused
used.
data will be removed.
Acha, okay, okay. To clear the unused memory.
Correct.
Okay, okay.
I personally used GC in one of the use case where my container memory was going very high. Okay, I read data from some database. It's a huge data. Everything comes to RAM, right? So I was
Mm.
transforming. Immediately after transforming, I don't need original data. So whatever variables I am referring, I reassign them. So original data is no more required. So I ran immediately GC. That clears the memory immediately. I will
Mm.
show that later, like how we use that.
నేను ఇది ఐడి ప్రింట్ చేశాను, షాపింగ్ది షాప్ కాపీది.
Okay.
సో డెఫినెట్గా వేరు వేరు వస్తాయి, ఎందుకంటే బట్ ఈ షాప్ కాపీ
Okay, let's print this way. I'll show you. Okay, go to that ID of shopping. Okay, then ID of shop copy. Then let's print ID of shopping of which. Okay, both are pointing to same, right? Which, which. You see now, this is first dictionary, that is shopping. It's a different memory location, right? Next is shop copy. That is also different memory location. But when we are printing the wedge value, which is a list, right? That is same. You see same memory location. That is the reason it is getting affected, though you took the copy. Okay. In real time, many cases you will see such data and you want exact backup. I want exact backup. If somebody is changing this, my copied whatever backup should not be affected. Thus, that use case is very valid in real time. That is what deep copy. Deep copy means you are copying everything. Here 1, 2, 3 it was referring same thing, right? Instead of referring to the same thing, what happens? It creates one more 1, 2, 3, let's say 4, right? Instead of referring to 3, 2, it will refer to 3, 4. Whatever nested levels you have, how many ever levels, everything is copied into different memory location in the deep copy. That is the main difference. In interviews, this question will be asked mostly. Difference between shallow copy and deep copy.
సారీ డీప్ కాపీ ఎలా డిఫైన్ చేస్తారు?
Exactly. Now, for that, we need to make use of one library called copy. Import COPI. Import when you want to use external Python code. Okay. The COPY is a different Python code that is available for us to use. It comes with the Python software when we install, right? There are so many modules will come. In that, copy is one of that, right? How do we create? Okay, now sharp deep copy. Copy dot deep copy. This is what I should do. Just understand that, okay, we have to import copy. Copy dot deep copy is the method to take a deep copy. What is this import? Why we are keep dot? This we have seen, right, in the list dot append. Same, this is a method available inside this module. But why we are importing, how this importing works, that we will see in the future classes. Now what we should do, okay, let's define this here only. Where is that? Okay, let's define this here, deep copy, and see the data. Print, I'm printing deep copy, then we are adding chili, then let's see how the data will be in all three. The remaining are not required. We will just see ID of again all three. Now where is this? Yeah, so this is the three copies we have taken. This is original one, this is shallow copy, this is deep copy, right? Then we added append chili, right? Append chili we added, that is affected for our shallow copy. You see the deep copy, it is not affected. Deep copy is third one we printed. If you see the memory location, right? Three different memory locations, but if you look at their inside list, right? Original, shallow copy are referring to same memory, but deep copy, it has created separate copy and stored separate memory location. That is what deep copy. Got it? No difference between shallow copy and deep copy. This is important in real time also. Sometimes you will get the use case where you need to retain the backup as is.
But where exactly is used actually? Like, because if you use a shallow copy, at least we can save some space and all, right? Memory and all.
Correct, but it
So
depends on your use case, right? If use case is demanding that, okay, I need to have a separate copy.
because it may impact, is it?
Right? My use cases, right? Where I wanted to create a new schema altogether using the existing one, right? Okay, I didn't tell other way around, right? Okay, that's good. It's not only shopping wedge, okay? If I change something on the copy also, so okay, let me now add one more. Append. I'm keeping one more caret. So it need not to be in the original one. Even if you change something on the shallow copy also, it will affect the original one because both are pointing to same memory, right?
Mm,
You see here, both are affected. So it doesn't matter where you are appending, in the new copy or original one. It still affect
original.
both because both are pointing to same memory, right? So in this case, imagine now I have some existing schema and I want to create a new schema, right? Suppose I have, let's say, name, okay, some name, okay, data, then let's say version, okay, zero something. Then I have some other data, okay, fields, right? Fields, let's say, okay, I should keep this in quotes. A, B, C. So this is what my existing schema. Just understand this way, right? So now what I have to do, I have to create a new schema changing C to D. That is my requirement. Okay. So version 1, there is no problem. You can change it. Okay, let's assume schema dot copy. This is what you are doing, right? So now what you do in the schema 1, you take version and you change it to 1. Okay. Now let's print both schema 1. You took the copy, well and good, right? You changed it to version 1. Now what is your requirement? you need to change your C to D, right?
Yes.
Fields, inside the fields, which index? Index 2. I need to change it to D. Okay, now this is what your requirement. You see what happened now? Your existing schema is also getting affected, which you are not supposed to do, right?
Hmm.
In such cases, we will need the deep copy. This is a real case which I worked upon.